So I allowed you on Tuesday last week to not see how these two or these three different orders came about. But I don't think you're really missing out on anything. I'm going to show you a couple of examples today, how this works. I do want you to see that the order of a reaction, as I mentioned, the order of a reactant does not tell how fast it goes. It just tells what impact that reactant has on the rate of the reaction. So what that means is this. If a reactant is zero order, that means its concentration does not affect the rate. The rate's going to be what it is regardless. You can double the rate. I'm sorry. I'll start over again. You can double the concentration of the reactant, and it wouldn't affect the rate. The rate is still going to be what it was before. So the zero order means that the reactant concentration has no effect on the rate of the reaction. However, if it's first order, that means if you double the concentration of the reactant, the rate of the reaction doubles. Whatever change you apply to the reactant's concentration, it's going to be the same change that happens to the rate. If you triple the concentration of the reactant, the rate will triple. That's what first order means. So again, as you see, it does not tell us how fast the reaction is. It just tells us how much the reactant concentration has to do with rate. If it's a second order, think of the order as the power on the reactant. Second order means that whatever you do to the concentration of the reactant, it's going to have that effect squared on the reaction rate. So if you double the concentration of the reactant, that means that it's going to make the reaction rate go up by 4. If you triple the reactant concentration, the rate goes up by 9. Okay? So you have more of an impact on the rate of the reaction from second order. It does not mean the reaction is faster, necessarily. Yes?
Wait, so for the zero order, you're not going to see like any difference in like reactants?
Right. Yeah, you can double the concentration of the reactants, but then the rate's still the same. It doesn't affect the rate.
All right, I see.
So we can always control what the concentration of the reactants are, but then we see how fast the rate goes. So just to remind you, this is what the reaction, the three different orders look like. We'll use